Alright, so this is what's called augmented matrices. These are the reasons that I had you set everything up with x's, y's, and z's equals the totals all lined up like so. The point is that we can plug it in, if in this format, we can plug it into our calculators like this. So all we do is drop the coefficient, or drop the variable. So it's like a 1x, that's why it's a 1 here. 2y, 2 here. 3z, 3 there. And just transfer all the numbers over. And this stands for the equal sign, but you won't actually see that in your calculator. Working in the other direction, if you have an augmented system, and this is what our answers will look like. The answers will look like this kind of a thing, with all ones along the diagonal, and then these. So if I was translating this into a system of equations, that's like 1x plus 0y plus 0z, which would give me 1x equals 3. This is like 0x plus 1y plus 0z equals 4. So that's y equals 4, and then 1z equals 1. So that solves our system. So if we could get our calculators to make something that started like this, starts like this, to look like this, and then get that to look like this, then we can get our answer. So then how are we going to do that? What we're going to do is, here's a system in here that you could get for a problem. We're going to turn this into a augmented system, so we have to make it look like a matrix. So that's going to be 2, 4, 8, and 3, negative 2, 4. Now to solve this in your calculator, we're going to go to the TI. And you have to look for my cursor here. So you go to second matrix. So the x negative 1, second, that button gives you the matrix. We're going to go over to edit, and we're going to create a matrix that looks like the problem we just had. So hit enter. Now the problem we just had was, this is a 2 by 3 matrix, so you have to know the dimensions, and it's always rows by columns. So it's 2 rows and 3 columns. So that's rows by columns. That's going to be very important that you have that correct when you're doing systems that aren't all set up the same. So sometimes they have 2 variables with 1, 2, 3 or more equations. So this is a 2 by 3, and that sets up the right size. And now we plug in the numbers: 2, 4, 8, and 3, negative 2. Oh, what happened? My bad. So we're going to go down here, negative 2. Okay, I have to use the negative button, my bad. So I guess if you hit minus on your keyboard, it doesn't work. And then there. Alright, so now we have this matrix. If I were to go to quit out of this, if I just went to the matrix menu and selected it, that will just show me the matrix. It's not going to do anything exciting. But it's a good way to check and see if I did it right. So here, big idea. This is how we're going to solve. Alright, so make sure you're paying attention. This is how we're going to solve. You go to matrix. We want to do some math. We go all the way down to RREF. Not REF, RREF. So we do that. That's the operation we're going to do. And what are we going to do it on? We're going to do it on matrix A. So we just names. I've only made one, but if you have a bunch, you just select the one you want. So that's A for this one. Close the parentheses. So this is like an operation, RREF, on this matrix. When you do that, it spits this out. So that is going to be our answer. This tells us that we have 1x equals 2 and 1y equals 1. So we have the x equals 2, y equals 1 for our answer. So please check Moodle for the associated assignment with this topic.